Okay, welcome, Andrew. So this one is InorderTraversal. We're implementing a type version of binary tree InorderTraversal. So don't worry about the English there. Let's go into the tests because this has nice tests. So
Sure.
We see that, okay, as a base case, if we get null as an input, then we just return an empty array. Fine. But we have this tree here thing. The tree has value left and right always. So we're looking at type of tree 1, and what we're expecting to get out is 1, 2, 3. So we have 1, and then we go to the right 2, and then we go to the left 3. We see we're doing it. I guess we're doing it from left to right. Okay, let's look at tree 1. Okay, so like this, I think actually A3 is the easier case. We're just grabbing the value. Here we see that we're going to go kind of up from the bottom. Does this make any sense to you?
I think so. Yeah. So we'll basically walk down the left side as far as possible before attempting the right as we kind of walk backwards.
Awesome.
Or walk back up.
Yeah. Okay, good. That makes more sense to you than it does to me. I'm not a computer sciencey guy myself. I pretend to be.
It's been a long time, but I think I know what we're doing.
Okay. All right. So like, how would you approach a problem like this?
Well, I think the first case I would want to solve is like the tree 2 or A3, I guess, the simple case of just one node and there's a value there.
Okay, so I'll set you up here. So we have like always we're returning an array, right? And then I didn't tell you. Oh yeah, we have like a funny kind of syntax on the challenges that we do that's not so normal in TypeScript land, just to keep things compressed because I'm trying to make it fit on phones for people. But
yeah, for sure. No, that makes sense.
Okay, so is this the right setup?
I think so. Yeah. So
we're already passing A1, which is cool.
Nice. Yeah. How do you see that you're passing A1? Sorry. Because when I'm hovering, like a C1 still shows as like a red.
Oh, it does?
False is on side of that constraint too. To me, it does.
Maybe your live share is not working. I'm not sure. Yeah, well, we'll debug that. I think we'll have to figure that out, but I promise we are.
Okay.
It's
cool,
because...
Cool. As long as you can see it.
Okay,
that works, I guess. All right, so let's see. Shall I just get started here, I guess?
Sure, yeah. What would you try to do?
So I think the first thing I want to do is just grab the value. Well, no. So first I want to check to see if there's anything to the left or the right. And if there's not, then we'll get the value at the current node. I guess that is essentially our base case for what is likely going to be a recursive type here, I think. So what we can do is check to see if... so we want to see... Oh, sorry, I'm just looking. Oh, yeah, there it is, tree node. So we want to see if the left or the right extends tree node, essentially. So first thing I would probably do in here is let's do t of left, if that extends a tree node. We're going to do something here. I'll come back to that. For now, I'm just going to put unknown. But if there isn't that, then we'll check tree t right, and see if that extends our tree node. And
I see what you're doing.
We're going to check that. And if neither of those are true, then we should probably just return tval.
Okay.
So I think
this is funny. So your solution is like really close. Instead of like putzing around, would you mind if I just dropped in, like you're like almost there? Would you mind if I just dropped in one of the solutions?
Let's do it.
Okay. So like, what you did is really, like, I love hearing your thought process of like how you thought through it. So here is a solution, or one of them.
Okay.
And this is basically kind of what you were saying. So the recursion happens in those places where you said, we'll figure out what we're going to do.
Yep.
We dive in on the left node if there's a left node, and we dive in on the right node if there's a right node. But otherwise, we stick the value in the middle. I guess I probably didn't explain that very well. I'm not sure I understood it very, very well either myself. But like we see, if we go look at B2, that we see we have the value, and then we have there's no left in this case, so we just go in on the right, and then we have the value, and then the thing that's on the left comes first. So we can sort of think through the second and third element of B2 as being like the first recursion.
Right. Yep. That makes sense.
What do you think about this one? Like,
what I'm trying to understand here is why, if the left side, because I see, because that's all on the right side of the topmost node in tree one. Cool. Yeah, that makes sense. I was thinking the left side should have come before the value, but there is no left side.
That's why I stopped you. Yeah, because I didn't explain it very well. Yeah, I think it's funny because
that makes sense.
There's so many ways to display these kinds of things. It's sort of arbitrary. Like, I don't know. If you did it like this, would it be that different? Like, I don't know. Let me show you. Okay, cool. So that's that one. Mm-hmm. I think it's kind of clean. I'm glad you like it. I like it too. I have another one here that utilizes some helpers. Oh no, this one doesn't utilize helpers, but let's take a look at it. It passes all the tests. What do you think about this one?
All right, so let's see. We've got a second generic type, which is a non-nullable tree. Okay, cool. And so how are we using that? So t extends null, we've got an empty array. Otherwise, we spread the left side, the value, and then the right side. I'm not sure I get how but maybe I haven't used the non-nullable
I think we could probably
it's t intersected with an empty object.
It's just to shorthand it. Yeah, we could do that.
Yeah, no, that makes sense.
Wait, no, we can't do that. Wait, what?
I think you've
type instantiation is excessively deep and possibly infinite is the error that I get. Produces a union type that is too complex to represent. Okay, so we can't do that. So it's probably an optimization then, I would say.
Gotcha. Yeah, interesting. I guess the idea is...
It's pretty much the same.
I see. Yeah, it's just... So if there is no left side...
Mm-hmm. If there's no left side, then we're passing in something here...
I'd traverse down the left side.
Right. We'll get back an empty array. So here's another one. This one uses some helper types, which is always kind of interesting. So like, here, let's split them up. So it basically does it all in line because those helper types handle, they return. I'm thinking they're probably going to all return empty arrays if they hit like an error case.
Yep.
So left, right, and val. Right. So they do the extends null check 3 times instead of once like the others. So I don't know. Before I tell you what I think, what do you think about this?
I definitely like the symmetry here between like the way we're using like val and left and right, and we all kind of have similar shapes. I like breaking it into multiple types because it can feel like if you're not super familiar with TypeScript, this can feel more accessible. You can kind of get familiar with each piece as it goes. Mm-hmm. Yeah, I like this.
So I disagree. Usually I love the splitting things into helper types. This is like the first time where I think it actually makes it harder because there's so much more stuff, even though they're all mostly the same and they're pretty simple. Like, I think I would rather have, if we go look at this one, like the first one maybe. Is like
I definitely clearer? Still like the first one best, I think, out of all of these.
Okay, so hold on tight. Yeah. This is the last example I have. So this one was interesting, I thought, because they take this approach here of wrapping T entry node in a tuple.
Yep.
You know,
conditional type distributivity. That is something I need to dive deeper into on TypeScript.
Oh yeah,
but okay. I'm like high level familiar with how that works.
We're gonna have a nice time today. It's basically like mapping, but for unions. So when you pass a union, when you put it in this context without these things, I don't think it would work without. Yeah, it would not work without these. When you put it in this context, if there's a union, it will TypeScript will kind of like pass that element to the union. Yeah, like you're mapping, like in functional programming kind of map. But
so that you're basically doing like a T extends tree node and then also T extends null because the sorry, that's not T is the tree node or null, right? So it's tree node extends tree node or null extends tree node.
Right.
Is that the idea?
Yes.
Gotcha.
Exactly. We could have flipped this to be, because the other one, like just to show it, let me put it on, like try to see if I can fit them on the same screen. So like here's the one we had up top. Like I think it was the second one. So you see like from like the innards is exactly the same.
Yeah.
Except we don't have to do this non-nullable part. See, we can just do T val. We can just do T right and T left. We don't have to do T extends null. So yeah, it's kind of a fun one. But okay, well that's it.
Cool.
That's InorderTraversal. If you were expecting more computer sciencey tree stuff, I'm sorry to disappoint you out there. But cool. Let's any other closing thoughts? If not, let's go to the next one.
Yeah, let's do it.